Ever looked at a massive artificial intelligence model and wondered how people actually built them? It helps to think of it less like writing code on a screen and more like assembling a high-tech, futuristic supercar in a garage. You take these highly complex components, neural layers, and stack them together, piece by piece. But without the right tools, you are essentially building this engine blindfolded, just crossing your fingers and hoping the car will start. And what usually happens? You turn the key, try to start the model, and nothing works. The internal math doesn't align perfectly. The entire system crashes instantly, right in front of you, just like an engine smoking on the test block. To get that engine running smoothly, you need a specialized set of tools. The Pytorch ecosystem has 4 specific libraries designed exactly for this purpose, to diagnose, fix, and upgrade your AI engine. Once you learn how to use these 4 tools, you stop guessing. Building AI goes from a frustrating cycle of trial and error into precise, predictable engineering. Let's open up the Toolkit. If we look closely inside our engine, the #1 reason it won't start for a beginner is something called a shape mismatch error. Think of your data flowing through the model like fluid in a pipe. A shape mismatch error is like trying to force a massive, high-pressure pipe directly into a tiny, incompatible valve. The dimensions are wrong, so the data physically cannot fit, and the whole system breaks down. This diagram shows how we fix that using a library called Torch Info, which acts like a medical X-ray for your network. As you can see in this table, it tracks exactly how much memory is being used and the exact size of your data as it moves downward through each distinct layer. That flashing red row exposes exactly where the math doesn't line up. Instead of digging through code to find the break, Torch Info prints this neat summary. Once you see the exact sizes leaving one layer and entering the next, you simply adjust the dimensions so they match, and the data flows perfectly. By making the invisible, abstract math inside your model completely visible, Torch Info saves you hours of staring at error screens. You spot the bottleneck, resize the valve, and move on. Now that the mechanical parts fit together, we have to wire the electrical system. In an AI model, this wiring is the flow of logic and data. You will often hear terms like computational graph or backpropagation. All this really means is mapping out a path for electrical current to travel forward through the car and then routing feedback backwards so the car learns from its mistakes. Look at this flowchart to see how we track that current using a library called TorchViz. TorchViz automatically generates this visual blueprint of your entire electrical system, laying out all the nodes and arrows to show the clear forward path and the returning feedback loop. When you have complex models with logic that branches off in different directions, things get confusing fast. TorchViz lets you physically trace exactly how that feedback travels backward through your network to find specific decision points. This tool ensures the actual math and data routing of the AI match what you intended to design in your head, preventing hidden logic flaws that would otherwise ruin your model's performance down the line. At this point, your garage-built engine works, but if you want to compete in a professional race, we need a serious power upgrade. Trying to build a world-class AI entirely from scratch using basic math parts is incredibly slow. You would spend years teaching it basic patterns before it could do anything useful. This is where the Transformers library from Hugging Face comes in. Using this tool is the equivalent of having a massive crane smoothly lower a pre-built, championship-winning Formula One engine straight into your custom chassis. Transformers gives you access to pre-trained models, like BERT or GPT. Because these engines have already processed millions of books, images, and websites, they come out of the box already smart, understanding complex language and vision right away. This library allows anyone working on a laptop to use the same cutting-edge technology as a massive tech giant, simply by taking these ready-made engines and fine-tuning them for a specific goal. Now it is time to roll the car out of the garage, get it on the test track, and open up the throttle. As your AI speeds around the track, how do you objectively measure how well it's doing? Is it actually driving accurately, or is it about to spin out on the next corner? This dashboard interface shows your performance in real time using torch metrics. Accuracy is your total score, but precision measures if the car is hitting its specific marks correctly, while recall checks if it missed any obstacles on the road. These stats give you a balanced view of the car's reliability. Torch metrics is special because it calculates these scores directly on your GPU, speeding things up and preventing a massive memory overload during the test drive. Without precise metrics, you are just guessing based on a feeling. Torch metrics provides the undeniable quantitative proof you need to know your AI is reliable enough to deploy in the real world. So here is your new workflow. Diagnose physical shape errors with Torch info, map out electrical logic with Torch Viz, drop in upgrade power using transformers, and track performance with Torch metrics. Using this ecosystem of Pytorch tools gives you a clear path forward. Instead of feeling lost when an error appears, you now have a professional process to find and fix the problem, putting you well on your way to building models that actually work. If this toolkit helped you understand how the pieces fit together, please drop a like on the video and let me know down in the comments what kind of AI project you plan to build first.